Good day, everyone. Today we are going to have more example on branching. So let's try to solve the given problem. So the problem states that we are to create a flowchart that accepts a three-digit integer, compute the average of the digits of the given number. Then we are to display the sum of the digits if the average of the digits is lower than 5. Otherwise, we display the product of the first two digits less the third digit. Now, what is asked of the problem? What do you think is the required output of the given problem? Now, if you are going to understand or dissect the problem, it actually asks us to either display the sum of the digits or the product of the first two digits less the third digit based on the given condition. Average is lower than 5. So if the condition is met, then we are to display the sum. Otherwise, we display the product of the first two digits less the third digit. Now, how do we solve this problem? Knowing that these are the needed output. So, of course, we need to get the input first, which tells us to accept a three-digit integer. So which means that the input is a number which consists of three digits. So say for example, the given number or the value entered by the user is 356. If this is the given value, which means that to get the average, we have to add the value 3 plus 5 plus 6, then divide it by 3. Okay? And if the result of this operation is less than 5, then we compute the sum or we compute the sum and display it. So which means that if this is the value, we are going to have a result of 14. If again the average is less than 5, but if the average of this three digit is 5 or more, then we multiply the first two digit, which would be 15 less the third digit, which is 6, then that would give us 9. So these are the possible outputs if we are going to make use of this input. So we are going to try later on if we would be able to come up with a flowchart that would give us this result. So let's start creating the flowchart. Now, the flowchart always starts with the terminal symbol, and the terminal symbol is represented by an oval. And of course, we have to label it. Okay, we have start. Then we want to make our flowchart be as user friendly as possible, so that when we convert this flowchart into a program and execute it, the program would guide the user on what to do. So here we would say display, enter a 3-digit number. So this is just to inform the user that what is going to input is a 3-digit number. Now I know that you would say, "What, sir, what if the user would input a 2-digit number? Or what if the user would input a number that has more than 3 digits? What are we going to do with that?" Okay, for this example, let's try to have an input that is just 3 digits. Okay, so we'll come to discussing how do we filter this kind of input later on. So after giving an instruction to the user on what to do, let's have an input statement that tells the user to input now the number. This is the statement that would accept the values typed by the user from an input device and store it to variable num. A variable num is actually a memory location wherein it will store whatever value typed by the user. Then we have to compute now or to extract the digits of the given number. So we have first to extract the last digit. So we have to extract first 6. And to do that, we say last digit is equals to num modulo of 10. Take note that the modulo operator, take note that the modulo operator gets the remainder of a division operation. It takes out the remainder. Okay, so which means that this operation L is equals to num modulo of 10, having a 356 input for num, that would give us 356 divided by 10, where 10 here is our divisor. So here we would be getting 35, and multiply it by 10, you'll get 350. The first remainder is 6. Okay, so that 6 will be stored to variable L. That's how we make use of the modulo operator. Now, since we were able to extract the last digit, let's try to extract the second digit, the middle digit. And to do that, we say second digit is equals to num modulo of 100, okay, minus L divided by 10. And why is that? Why is this the operation that we do? Now, num modulo of 100, so which means that the divisor that we have here is 100. So we have 356 divided by 100 will give us what? It will give us 3 multiplied by 100. You'll have what? 300. And you'll get 56. Okay? So we have 56 as the remainder. We subtract the value of L where L is equals to 6. So this becomes the operation inside the parentheses becomes 50. Okay? And when we divide it by 10, we are going to get 5. And 5 will be stored to variable S. Okay? So we have the last digit and the first digit. Now we get the first digit. And how do we get the first digit? So we say first digit is equals to num minus the value of S. or rather num minus num modulo of 100. And what is num minus num modulo of 100? That is equal to 300. Why? Num modulo of 100 again is 56. And when we subtract 56 from 356, we are going to get 300. Then with that, we divide it by 100 to extract the first digit. And f now will hold a value of 3. So now we are ready to get the average of this digit. And we say average is equals to L plus S plus F divided by 3. And the result of that, we are going to test if the value of average is less than 5. If the condition is true, we say sum is equals to L plus S plus F. Then we print the value of the sum, print the value of the sum then its value. Okay, then we stop, we terminate our flowchart, and if the condition is false, we have to say P is equals to the first digit multiplied by the second digit minus the last digit. Then we say print the value of P. Then let's just have an on-page connector here, and that's it. So we now have our flowchart. So let's try to trace our flowchart if it would really give us that correct result. So let's have input number. Now, again, let's try to have another value aside from 356 since we already have discussed this. So let's say, for example, we have numbers 1 to 3. Okay. So here, the numbers 1 to 3, we first extract the last digit, wherein last digit is stored on variable L. Okay. So we have L is num modulo of 10. So that means 1, 2, 3 divided by 10. We get the first remainder, and it would give us 12, 120, and the first remainder is 3. So 3 is stored on variable L. Now we have the second digit is num modulo of 100. That is 1, 2, 3 modulo of 100. That will give us what? It will give us 1. Multiply it by 100, we'll get 100. You have 23 as your remainder, less the value of L, which is 3. We are going to get 20 divided by 10. We are going to get 2. So S here will have a value of 2. Then we have F is equals to num, which is 1, 2, 3 modulo of 100. We are going to what? Get 23 here, or rather 100, you have 23. Okay, subtract that from num, which is 123. We are going to get 100. divided by 100, we are going to get 1. And f here will have a value of 1. So we compute the average. What is the average of 1 plus 2 plus 3? That is 6 divided by 3. That will give us 2. And since the average is 2, we check on the condition is 2 less than 5. The condition is true. Then we compute the sum, which is 1 plus 2 plus 3. That would give us 6. And sum is equals to, it displays the word sum followed by the value stored on variable sum, which is 6. And after that, we end our flowchart. Okay? So what if the value entered by the user is, instead of 1, 2, 3, we have 9, 7, 8? What happens? So again, we have L equals to num modulo of 10. What do we get from that? Okay, we get the value of 8. So L will have a value of 8. Then num modulo of 10 of 100 will get 78 minus the value of L, which is 8. That would give us 70 divided by 10. S now will hold a value of 7. Then you have num, which is 978, minus num modulo of 100, which is 78. We are going to get 900. Divided by 100, we are going to have 9 for F. So we add this, we get the average. We have 9 plus 15. That would give us 24. Divided by 3, that would give us 8. So is 8 less than 5? The condition is false. Then we multiply the first two digits, and the first two digit is 9 times 7. That would give us what? What is 9 times 7? 63. Am I right? Yeah, it's 63 less the value of 8. That would give us 55. Then we print 55 on page connector to stop, and that ends the flowchart. So you can try solving this your own and come up with another solution instead of following what is there, what we have here. Okay? Thank you for listening, and let's have another problem on the next video.